All right, so we're given this problem: tire pressure monitoring system warns the driver when the tire pressure of the vehicle is 27% below the target pressure. So basically that means if this first part here, at what PSI will the TPMS trigger a warning for this car? Well, if it's below, and don't really need to use Excel here, but I'll just go ahead and show it. That means anything above the 27%, which you know the two probabilities have to add to 1. So that's where I'm going to get the 7.3. Okay, so this is below, this is above, so that would be fine. And it says here that suppose the target tire pressure of a certain car is 32 psi. So all I would have to do, let's just say that's the target, is to take, for part A here, the 73% above times 32, and this would give me my targeted mean. All right, so that's part A. All right, part B says suppose the tire pressure is normally distributed with a random variable and a standard deviation equal to 3. So now I have a standard deviation equal to 3. If the car's tire average pressure is on target, well, in this case now, let's get our target here. This was the mean that was given. This is what we computed for our target. What is the probability that it will trigger a warning? So the key here, and it's kind of nice to actually draw this out a little bit, is to understand that you were given the mean is right here in the middle of 32. And so basically what we're looking for, if we're somewhere down here of this target, we said that's fine, that's okay. So what I want to know, how to find this probability right here. Well, you could actually do the Z, where you take your value, 23.36 minus 32, and they told you what the standard deviation is, 3. So 23, well, I guess I could do that over here. So my Z would equal, don't forget to open a parentheses to put all this on the top, minus 32, and then divide it by 3. So that would give me my actual Z score, which makes sense. It's below the mean, so it should be negative. And I could go to a table and look this value up. However, Excel has where if you don't want to look the table up, they actually have where you can directly find the probability without the table. And that's using this norm.dist, hence normal distribution. Notice when I open the parentheses, it tells me what it wants. It wants my X value, which is my target. It wants my mean, and this would be a good way to show to actually reference cells. And then it wants my mean, which is the 32. And then the standard deviation. And cumulative says to add from all the way to the bottom up to that 23.36, which certainly I want to do. You can put true, or 1 is the same thing as true. And when I hit enter, that's the probability. Now, on this assignment, they want you to round this to 4 decimal places, so I just changed the decimal rounded to 0.0020. All right, so that is part B. Here it says the manufacturer's recommended correct inflation range is between 30 to 34. I want to know if on random they pick a tire, what's the probability it would be between that range. So again, this is really important that you understand visually what you're looking at. So 32 was the mean. Between 30 and 34, so what I'm looking for is this probability between those values. So again, you could either use the table and find the Z values and look those up, or you could find this probability all the way from the bottom up to the 34, this probability, subtract the 2, and that would give you the actual middle piece. So the easiest way to do that, you can do that in one step. So in other words, the probability that we're between 30 and 34, I'm going to use the same norm.dist. It would make sense I need to use the upper value, the 34, okay, because that's what I said all the way up here. And then my same mean, my same standard deviation. I want all that cumulative. I close the parentheses. Now notice in the same step, I put a minus and I do the norm again. And you could do this in two different steps. I just do it one step. And now I'm going to do the 30. And then my same mean, my same standard deviation, and I do want that to accumulate. Okay, so that gives me here this one formula. Says find the probability all the way up to 34, find the probability all the way up to 30. Notice when you subtract that, that gives you this middle area. And so I hit enter, and once again, I can format this so it's rounded to 4 decimal places, and that's how you get that probability.